This is CPM Calculus, Chapter 3, number 190. Determine where, algebraically where, y is equal to x cubed plus 3/2 x squared minus 6x plus 2 is decreasing. Then check with the graph of y on your graphing calculator. How did the derivative help? Well, okay, the derivative, how's that going to help? Well, we know that if wherever it's decreasing, right, we know that this would mean the derivative is negative, right? So that is going to be where we get our help from. So let's find the derivative. The slope function y prime is equal to 3x squared. I'm using the power rule. Bring down that 2. 2 times 3/2 is 3x minus 6. Okay? That's the slope function. Well, what else can we do? Well, we know wherever this is, right, this function, it's basically a parabola, right? It's a quadratic. Squared is the term. We know that it's going to cross the x-axis, right? It's going to basically do positive. It's going to be something like this, right? So wherever it's 0, right, are the endpoints. In the middle is where it's going to be decreasing. I mean, not decreasing. Where our function is decreasing because y prime is less than 0. It's below the x-axis. All right? So let's go ahead and say, well, 3x squared plus 3x minus 6 is equal to 0, right? So that's going to give us these boundary points where y prime is equal to 0. Y prime equals to 0, right? That's the zeros. Let's solve for this. Let's factor out 3 plus x minus 2 is equal to 0. Can we factor this? Well, we could divide both sides by 3 first, right? If we divide 3 over here and there, we just get x squared plus x minus 2 is equal to 0. Then I can go ahead and look, well, what terms can I multiply to get negative 2? I'm using the x to factor this, the x method, and add to get 1. Okay, so 2 and 1, right, multiplied, we'll get, well, 2 and negative 1 multiply to get negative 2, and add to get positive 1, okay? So that means we could factor this to be x plus 2 times x minus 1. So solving this, we know x plus 2 is equal to 0, or x minus 1 is equal to 0. When we multiply, one of those has to be 0 for this to be true. Subtract 2 from both sides of this side, we get x is equal to negative 2, or add 1 to both sides, x is equal to 1. All right? So y prime is 0 at x is equal to negative 2, and y prime is 0 at x is equal to 1, right? So that means in between, y prime is negative. Okay, well, what if I didn't know that? I can check to the left. Basically, I know that it hits 0 here at negative 2, hits again at 1, right? It doesn't hit it before 2, so I know it's either above it until 2 or below it until 2. Between negative 2 and 1, I know it's either above it or below it, right? Because it's not crossing it before we get there. And again, after 2, it's either above or below because we know it's not crossing it again after 1. Okay? So we can check a value. We can check, well, what about at x is equal to negative 3? What about when x is 0? What about when x is 2? And then we can find out, well, is y prime positive or negative in this region? Is it positive or is it negative? Is it positive or is it negative, right? In these regions, and then that will tell us, again, where our original function is decreasing, okay? Because where y prime is less than 0 is where our original function is decreasing. Okay, so let's go ahead and let's do this because we know it's between negative 2 and 1, but let's algebraically confirm that at negative 3, at x equals to negative 3, y prime is equal to 3 times negative 3 squared plus 3 times negative 3 minus 6. Again, this is y prime, so I'm just plugging in x to be negative 3. 3 times negative 3 squared is 9 times 3 is 27, minus 9 minus 6, okay? So that would be, what is that? 27 minus 9 is 18. Yes, 18 minus 6 is 12. Okay? So we know that it's over here to the left is positive, right? So that means it hits 2 and it goes up. It's positive. In between, let's try at x is equal to 0, y prime is equal to 3 times 0 squared plus 3 times 0 minus 6. That's negative 6. So I know over here it's negative, right? 0 is negative. Negative 3 is positive. So that means I know in between here it goes down, just like we know. Because we know it's a parabola shape, so we know how it behaves. And also at x is equal to 2, y prime is equal to 3 times 2 squared plus 3 times 2 minus 6, which is 4 times 3 is 12, plus 6 minus 6 is just 12. So again, we get positive 12, so it's over here on the positive side of the x-axis. All right? So this tells us, again, where is our function y decreasing? Well, it's decreasing. Y is decreasing in the same region where y prime is negative, and that's between negative 2 and positive 1. All right? Between negative 2 and positive 1, let's go ahead and graph that and check. Okay, let me get out the calculator. Let's use this one. Why not? Okay, so what is y? Y, again, is x cubed plus 3/2 x squared minus 6x plus 2. Graph. Okay. Did I do this? Where is it decreasing? Yes. All right. Let me zoom out. Zoom standard. Okay. So I can see here it's decreasing. So it's increasing until this value, right? And then decreasing and then increasing again. So let me zoom. Let's just change my window to go, change the y value to go from, I don't know, -5. Let's make it -5 to 15. Okay, so there I can see where it's decreasing. And remember, I can go ahead and find exactly where's the maximum. So let's do 4. Your calculator does a maximum because I can get these exact values to find out what region is decreasing. So let me select there and here, right? Because I'm trying to help my calculator find out the point. So it starts decreasing at x is -2, right? Perfect. Bam. -2 confirmed. Where does it stop decreasing, this function? Let's calculate it again. Where is the minimum now? Because we want to get this point all the way at the minimum because that's where it stops to decrease. So I can use my calculator to help me find that. Okay, so again, bam, it stops at 1. All right, so the calculator confirmed that this is the correct region. Okay, so how did the derivative help? Well, this is how the derivative helped, right? The derivative, let me get more space, is y prime. There we go. All right, so this is the end of CPM Chapter 3, number 190 from Calculus.